Example 6. Find the real zeros of f. Use the real zeros to factor f. F of x is equal to x cubed plus 6x squared plus 6x minus 4. All right, we're going to follow the procedure outlined on page 4. The first thing we're going to do is recognize the degree of this polynomial function and write down what that tells us about the maximum number of zeros. So if you scan this polynomial function, the highest power of x is 3. So this is a third degree polynomial. So we can go ahead and say this is a third degree polynomial. So the maximum number of real zeros is 3. Okay, and remember, I've already told you, we're going to be looking into imaginary zeros in the next section. They are popping up in this section a bit, but you'll see it more in section 5.3. And I've already told you that the number of imaginary zeros plus the number of real zeros, if you're factoring in multiplicity, that has to add up to the degree. Okay. Actually, there's a picture of the graph right here, and if you just quickly scan it, you see 1, 2, 3 x-intercepts. Okay, so since this is degree 3 and there's a max of 3 zeros total, you can see that they're going to be real. They're all going to be real because you see 3 distinct x-intercepts present on the graph. Okay, so expect all the zeros to be real here. Okay, all right, so in our next step, okay, we have to come up with the list of possible rational zeros. That's the P over Q thing. Okay, so we're going to make a list of possible rational zeros. Okay, all right, so let's do our plus or minus P over Q. Okay, so remember, we're going to generate this whole list of possible zeros for this polynomial function. So you have to have a plus or minus in front of each of these numbers, but I'm just going to start building the list and then we'll clean it up. The P is referring to the factors of the constant term. Okay, so when you look at your polynomial, 4 is the constant term. You don't have to worry about the sign because the sign is being cared for with the plus or minus. Okay, so we're going to have the factors of 4 in the numerator. The bottom number, the Q, is going to be the factors of the leading coefficient. The leading coefficient here is 1. Okay, so let's go ahead and write this down. Okay, so we're going to get plus or minus in the numerator. Think of pairs of numbers that multiply to give you 4. Well, 2 times 2, and I'm not going to list it twice, okay? I'm just going to list 2 once, but 2 times 2 gives you 4, and then also 1 and 4. 1 times 4 gives you 4. Okay, those are the factors of 4. In the bottom, we need to write down the factors of 1. Well, the only 2 numbers you can multiply together to get 1 are 1 and 1. Okay, so we're just going to write a 1. Okay, so this is not going to be a very big list at all. Okay, so if we go ahead and write these out, okay, this is going to be, we're going to take every number in the top and divide by everything in the denominator. So we'll start with the 1. So we're going to have to do plus or minus 1. 1 divided by 1 is 1. And then we're going to have plus or minus 2 divided by 1 is going to give us plus or minus 2. And then lastly, we're going to have, take the 4 and divide by 1. We're going to have plus or minus 4. Okay, so there's only 6 total possible rational zeros here. Okay, all right, let me go ahead and box this. This is our list. And then in the third step, we need to consult the graph. We're going to have to start our synthetic division process, and we need to choose one of the zeros as a starting point. Okay, we're going to try to match up our graph with something on this list. Okay, all right, so let's do that. Okay, so in step 3, we're going to consult the graph. Okay, again, I've provided you with a good picture of the graph. Okay, so let's go look at this. We already said there appear to be 3 real zeros. Okay, and when you're looking at these and you're trying to match up what you see in your list of possible zeros, it looks like we have a match right here. Okay, you know, this first zero right here is somewhere between -5 and -4. And if you look at your list of possible zeros, we don't have any fractions that are between -5 and -4. So that's interesting. We'll talk about that. Same thing with the third zero over here, the one between 0 and 1. In our list of possible rational zeros, there's no number that's between 0 and 1. So that's also interesting. However, it does appear that -2 is a 0 for this graph, and it is in our list. So we're going to use -2 as our starting zero for synthetic division, okay? We will definitely address what's going on with these other two zeros, okay? Since we don't see anything that resembles a number between -5 and -4, and also a number between 0 and 1 in our list of possible zeros, okay? All right, so we have consulted the graph, okay? It appears that x equals -2 is a 0. Okay, so we're going to start the synthetic division process. Okay, we're going to go up to our original function here. It is in standard form. We've got descending powers of x. We're going from the third power to the second power to the first power to the constant, so we don't have to have any zero placeholders. We're going to write down our numbers that we see. So we have +1, +6, +6, -4. Okay, so let's go ahead and write that down. So we've got 1, 6, 6, and then -4. And then remember, you're going to be dividing by something, and what goes out front? Well, it's going to be the zero, the number that we think is the 0, and we think -2 is the 0. If we do this synthetic division, we should get a 0 remainder, and that will confirm that x equals -2 is indeed a 0. All right, so let's do our synthetic division. We've set it up, so we're going to bring down the 1, and then we're going to multiply. 1 times -2 is -2. Now add 6 plus -2 is +4. +4 times -2 is -8. Add 6 plus -8 is -2. Multiply -2 times -2 is +4. -4 plus 4 is going to give us 0. Here is our 0 remainder. Okay, so that means that that confirms that -2 is indeed a 0 of the polynomial function. Okay, so remember, this is corresponding to the factor x minus a -2, which is x plus 2. Okay, so I'm going to go down here. I'm going to start filling in my information. We have just confirmed that x equals -2 is a 0 of the polynomial function. Okay, so if we have x equals -2, make one side equal to 0, so add 2 to both sides. Okay, the corresponding factor is going to be x plus 2. Okay, because if you took this factor x plus 2 and you set it equal to 0 and solved, that would give you the -2. Okay, so we're building our factorization. Okay, all right, so here we go. We need to figure out what's going on with these other zeros. Okay, the great thing about doing synthetic division is that once you get that 0 remainder, then this bottom line is going to tell us the other factor. Okay, we started with a third degree polynomial, so this last line here, we're going to go down in power by 1. So the other factor, x plus 2 times the other factor is going to be 1 times x squared plus 4 times x minus 2. Okay, so go ahead and write that in. Okay, so we're going to have the other factor is 1 times x squared, that's x squared, plus 4x minus 2. Okay, all right, so we're getting there. Okay, so now we're going to be working with the factorization to get the two other zeros. We know there are 3 distinct real zeros from the picture. Okay. All right, when you factor, you need to factor completely. So you have to factor until you can factor no more. The x plus 2 is not going to break down any further, but we need to concentrate on trying to factor this x squared plus 4 minus 2. Okay, that is quadratic. That should be easy for us to factor, from normal techniques. We won't have to use synthetic division again. Okay, and in fact, it would be difficult to use synthetic division again because we don't know exactly what these other two uh, zeros are, okay, because they're decimal numbers, okay? All right, so let's go over here. Again, our goal here is to try to break down this x squared plus 4x minus 2. Okay, so I'm going to come over here. Okay, I'm going to write down, I'm going to use a different color so we can kind of separate what we've already done. We've got x squared plus 4x minus 2. Okay, we are trying to factor this guy. Okay, and in the technique for this type of quadratic expression is you would have to find two numbers that multiply to be the constant, which would be -2, and they would have to add up to +4. Okay, so you need two numbers that multiply to be -2, and I can think of -2 and 1, or 1 and -2. Those are the combinations for multiplying two numbers that multiply together to be -2. But then when you add these numbers, they don't add up to 4. -2 plus 1 is -1. 1 plus -2, or sorry, I should have done it this way. The other combination is 1, -1, 2. If these two multiply to be -2, but they add up to +1, okay? So what that tells me, and maybe you don't know that technique, and that's okay, but if you try to factor this, it's not gonna work, okay? This is one of those polynomials. This is a second degree polynomial that it's been reduced to. It does not factor. So that doesn't mean you're out of luck, okay? You have to use the quadratic formula, okay? This is second degree. You can use the quadratic formula on it, okay? So a is going to be the number in front of x squared. It's going to be 1. B is going to be the number in front of x. That's 4. C is going to be the constant, which is -2. And you need to solve this because remember, we're trying to figure out when this is equal to 0. You need to plug into -b plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay? All right, so here we go. Plug in. We're going to get -b plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, that's how you plug into it, and we need to simplify. Okay, let's start by figuring out what's under the square root. We're going to have -4 plus or minus the square root of 16. Minus times minus will turn plus, and then 4 times 2 will give you 8 over 2. Okay, so this is going to be -4 plus or minus the square root of 24 over 2. Okay, we need to break down that square root of 24. Okay, so I'm going to come out here and make a factor tree. 24 breaks down into 8 times 3. 8 breaks down into 2 times 4. And then 4 breaks down into 2 times 2. And so now we're going to circle all the numbers at the bottoms of the branches. Okay, so 2 times 2 is 4, times 2 is 8, times 3 is 24. So if you're breaking down the square root of 24, it's the same thing as the square root of 2 times 2 times 2 times 3. And then remember what you need to do. You need to find a pair. I have a pair of 2's, scratch them out, 1 comes out, and then underneath the radical sign there are no other pairs. So 2 times 3 stays underneath, and you end up with 2 square root of 6. Okay, square root of 24 is the same thing as 2 square root of 6. Okay, so if we come down here, we're going to get -4 plus or minus the square root of 24 is the same thing as 2 square root of 6. Okay, and then in the bottom we have to divide by 2. Everything gets divided by 2. The -4 gets divided by 2, as does the 2 square root of 6. Okay, and then that's going to simplify to be -4 divided by 2 is -2 plus or minus 2 divided by 2 will cancel, leaving you the square root of 6. Okay, so what this is telling us what the other two x-intercepts are. Okay, so basically the first x-intercept that we see, we're going to choose the positive sign in the middle. That's going to be -2 plus the square root of 6. And then the other one is going to be -2 minus the square root of 6. okay? And if you pop these numbers in the calculator and look at their decimal approximations, they should match up with these other two zeros that we see in the picture, okay? So let's check it out, okay? I'm going to type in x1 first. So -2 plus the square root of 6. -2 plus the square root of 6, okay? This is about 0.45. So if we go back and look at our picture, okay, here it is. This could be the approximately 0.45. So this is going to be -2 plus the square root of 6. Okay, and then now we're going to type in -2 minus the square root of 6, and it should give us a number between -5 and -4. Okay, so let's punch it in. This is going to be -2 minus the square root of 6. And there you go. Okay, -4.45 approximately. Okay, so this other x-intercept, the third one, is -2 minus the square root of 6. Okay, all right, so we're going to go ahead and put these in my list of zeros. Okay, these are funny numbers, but they're real numbers. They're not imaginary. Okay, so we have 1 0 at -2. We have another one at -2 plus the square root of 6. And then we have the third one at -2 minus the square root of 6. Okay, now the question becomes, why did we not have these in this list of rational zeros? Okay, and the answer is these two numbers, -2 plus the square root of 6 and -2 minus the square root of 6, they are irrational numbers. Okay, if you go back and you look at their decimal expansions, they do not repeat and they actually keep going forever. You can't write these things as fractions. For example, if I tried to convert this last number to a fraction, you can't do it. Okay, rational means it has to be written as a fraction. Okay, so the moral of the story here is there could be zeros to your polynomial function that do not appear in this list of possible rational zeros. You could have an irrational zero, which is again a number that cannot be written as a fraction. It's a number whose decimal expansion continues forever and does not repeat. Okay, those are typically numbers that have square roots in them. Square roots that you don't know off the top of your head. Like we don't know what the square root of 6 is off the top of our head. It's some nasty decimal. Okay. All right. So we have one more thing to do. We know all three real zeros. We need to completely factor the polynomial function. Okay. All right. We need to break this down. Okay. We know that when we set this, what I just highlighted in yellow, when we set that equal to 0, we got the two x-intercepts, -2 plus the square root of 6, and then we got -2 minus the square root of 6. Okay, so what we're going to do here, I'm going to go over here. All right, I will use a different color again. Okay, we got x equals -2 plus the square root of 6 is a 0. Okay, so we're going to convert it to a factor. So we need to move everything over to one side and make it 0. Okay, so I'm going to add 2 and I'm going to subtract the square root of 6. Okay, so we're going to get x plus 2 minus the square root of 6 is equal to 0. Okay, this is going to be the corresponding factor. Okay, so here we go. Okay, I'm breaking this down again. Okay, we're going to get x plus 2. That doesn't break down. Okay, and then we're going to have x plus 2 minus the square root of 6. Okay, and then this third x-intercept will also turn into a factor. Okay, we've got the third x-intercept is going to be x equals -2 minus the square root of 6. Okay, move everything over to one side and set it to 0. So we're going to add 2. We're going to add the square root of 6. Okay, so we're going to get x plus 2 plus the square root of 6 is equal to 0. Okay, here is the last factor. Okay, so here we go. It's going to be x plus 2 plus the square root of 6. Okay, this is how you completely factor this polynomial function. Okay, it looks like a strange answer because we have square roots in our answer. Okay, but this x squared plus 4x minus 2 does break down according to its x, the corresponding x-intercepts, okay? So if you are asked to factor completely, okay, you may have to do something like this, okay, and your answers can look funny, okay? So make sure you understand how to do this particular example